Good evening, everybody, and welcome from wherever you might be in Southern Africa. I see there's a couple of Victor 51s as well that I quickly scroll through. Welcome to Namibia. And yeah, what's nice is about we're all within meteor scatter range of each other. So 2,000 kilometer range is sort of the optimal maximum that we can work with meteor scatter. And then the minimum, I would say, is about 400 kilometers. We can do more. We can do less, but then we have to both be in the same direction, but more about that a bit later on. All right, so tonight we're going to talk about meteor scatter, MSK 144. So let's have a quick look at worldwide activity. Now, this is a screenshot I grabbed yesterday morning, Sunday morning. And you can see, if you go to PSK Reporter and you go 6 meters and you go MSK, and you can see the last 6 hour activity or so. You can see North America very busy, Europe very busy, and then he came to South Africa. I think that was just me and Johnny at that point in time talking or making communication via meteor scatter. So at South Africa, or ZS is lacking behind a bit in this type of communication, and I think it's just lack of exposure to it. So that's the whole aim of tonight, is to give you a little bit more exposure to the newcomers into meteor scatter. You know, normally the guys, they get licensed and they get exposed to HF immediately. They don't get exposed to VHF so much. The exposure they do get is maybe into repeaters or maybe DMR or something like that, but never into simplex VHF, 6 meters, 2 meters, 70 cents and above. So we're trying to improve that bottom of the red Southern Africa sort of meteor scatter activity. In the past, it used to be very, very busy. Probably here from 2000 to 2010, activity was quite high on meteor scatter. When old man Hal ZS6 Whiskey Bravo was still driving it a lot. And yeah, so since it's just gone down and down and down. But you know, I think it's also a lot of old timers like myself, we remember it and we still use it. But the newcomers that come in nowadays, some of them has never even heard about meteor scatter, never mind moonbounds. So both of those activities are activities that happen in ZS. There's quite a couple of that do moonbounds as well. And maybe you can do a presentation on that on another time. But tonight we're just going to talk about MSK 144. All right, so what is MSK 144? Now, every day as Earth rotates and travels through space, it gets exposed to millions and millions of meteors that enter our atmosphere. Now, the distance from Earth to where they enter is about 80 kilometers, and then there's a 40-kilometer sort of band where these meteors enter, and that's where they encounter the friction when they enter the atmosphere and they burn up. When they burn up, it leaves an ionized trail, and those ionized trail is then reflective to radio signals. Now these burns is a couple of milliseconds, so it's very, very fast. During annual meteor showers, of which there's one, I think, at the moment, or not, I think it reaches its peak. You can do even SSB meteor scatter. There's so many of them that you can actually have an SSB communication on 6 meters, 2,000 kilometers far via meteor scatter. But there's nobody there. There's no activity, there's nobody to talk to. If you go and you Google and you'll see overseas, it's quite popular. But in ZS, it's just lacking. So what we've got here, we've got two stations. There's station A, there's station B. They're both pointing towards each other, maximum of 1,900 to 2,000 kilometers. And then you have to just wait for a chance that this meteor, and there is millions of them entering the atmosphere, will actually burn out between the two of you, creating a perfect angle for your signal to be reflected to station B. What makes this nice is that there can be 20 or 100 stations on exactly the same frequency, and they will not interfere with each other, because all of these angles at which the meteors enter the atmosphere is going to be different. is going to be different. So the one station might hear a station, and the other one will hear nothing. Or you'll hear another station a little bit further away. So that makes it nice that all of us can be at the same frequency at the same time, making communication and not interfering with each other. Obviously, if two stations are very close to each other, they must just go into the same period, and then they won't interfere with each other. But more about that just now. Right. So what is meteor scatter? The description: communication by bouncing radio signals of short-lived ionized trails of meteors in the E layer of the atmosphere. These trails can reflect frequencies between 30, 50 megahertz and also 144 and 432 megahertz. 144 and 432 megahertz takes a lot more power and a lot more patience. It can be done. I've done 144. I don't think there's anybody in ZS that's ever done 432. 432, they say you have to have at least a kilowatt to get some decent reflections of them. So how do you use it in amateur radio? It enables contacts over typical distances of 400 to 1,000 kilometer miles, well, about 2,000 kilometers, often during a brief propagation windows. So how does this work? What is MSK? The mode specifies MSK 144. What it means: medium shift keying at 144 baud rate. So that's the speed at which this signal is being transmitted. In the digital mode, we're using WSJTX. Is the main design. There's a couple of clones of it as well, which also works very well. But everything is coming from WSJTX, which is the main designer. And other guys have built around that, and they also use that. And it's designed for efficient meteor scatter QSOs. How does it work? Two stations exchange brief cross sign transmissions during alternative 15-second intervals. Transmit, receive. So in other words, I transmit for 15 seconds while you listen. Then you transmit for 15 seconds while I listen. So why do we use 50 megahertz? The advantages: 6-meter band is politically active and accessible for most meteor scatters with MSK 144. Being widely adopted, 50.260 is the main calling frequency. Now the thing is, most radios these days, HF radios, or new modern radios, come out with 6 meters already built in. So 99% of the time, only the HF part of it is being used. The 6 meters is just there by the wayside, and nobody really uses it. But yeah, you can use it. There's TEP openings in Europe, the East, Japan, China. This year we've worked right through. I think some states has even worked into Australia, but I've worked into Japan, China, yet to work into North America, but the whole of Europe and Northern Africa is available, and you can work it on 6 meters as well. But yeah, a Yagi is preferable for all of that. Okay. Required equipment. Accessory components: you need a transceiver capable of 50 megahertz or 6 meters, a computer running WSJTX, the modern version. There's a lot of older versions, but they stop working after a while, and then you have to download the later versions. There's always improvements happening, and that's why the version changes happen, new features being added, which is a lot beneficial for not just meteor scatter, but for all other weak signal modes as well. Believe it or not, but yeah, FT8 is also a weak signal mode, because you can work FT8 while you normally won't be able to work the cards on SSB. Eh? But yeah, Q65 can even work weaker signals. But back to MSK, you need a interface cable. Nowadays, the modern radios all come with USB, so you can interface with the radio directly from your USB port. It will carry the PTT, the cat control, and the audio via the USB cable. If you don't have that, you'll have to make one up. There's a lot of other third-party stuff you can also buy to get it onto USB. Then you need a beam or Yagi, 6 meters. Even a couple of guys have been using dipoles, and it also works. Typical power 330 to 100 watts is sufficient. Higher power, increased chances of quicker and better success if you can run, let's say, 400 or 500 or 600 watts. Configuration settings, I'll look onto that onto the slide just now, taking it up itself. But yeah, you need to select the mode MSK 144. Frequency tolerance around 200 Hz. Bandwidth 1500 Hz. The transmit cycles, transmit receive cycles is normally about 15 seconds. The most northern station normally takes this first sequence. If I'm speaking from KZN to Gauteng, I will be second. If I'm speaking to a station in Cape Town or London, then I will be first and they will be second. Right, so Cape Town guaranteed will probably always be second. Right. The last feature is to use PSK reporter for spotting. So you can see there, if both stations are connected, their laptops that they're working with is connected to the internet, or even if just one of them is connected to the internet, you'll be able to see the spots popping up as the QSO is in process. You won't know where in the process the QSO is, you just see that contact has been established. Right, when to operate. Your timing is important. Last night, myself and Dick ZS6BON I wanted to make a video just to show you guys how Meteor Scatter works. So I wanted to do a live presentation tonight, but we tried last night and we probably sat for an hour with virtually no pings. It was very, very quiet last night. So timing is very important. Although they happen 24/7, we did get pings, but it took a very long time to complete the QSO. So we actually stopped before we completed the QSO. We got together again this morning at about 7 o'clock, and we completed the QSO within 5 minutes instead of an hour. So general time, Meteor Scatter works 24/7, but best results are around local one. So early in the morning, when meteor trails, activity is higher. During meteor showers, Perseids or Geminis have increased activity. Special operating events like overseas, they have them, and ZS obviously we don't have them. During these events, they have special contests happening in these during these meteor showers. That's something that we're aiming to, is to get more guys active so that we can also have this weekend contest and then a year-long contest as well. Operating tips for real-life world experience. Antenna polarization is important. You have to make it horizontal. You can't make it vertical. You need to spread that signal out as wide as possible. If you make it vertical, it won't be spread out. It will just go in one plane. It will be spread out vertically down to the ground and up, and not across the skies. For better signal and wider shared sky area. Patience is key. It may take a couple of cycles before meteor trail yields any successful ping or contact. So yeah, you'll see just now when I'm going to show you the video that I get a ping from Dick, and then he gets a ping from me, and then 3-4 cycles there's nothing. But it's not that we're not transmitting, it's just we're not receiving anything. So it's not a mode where you can just really turn on the radio and you're going to hear something. There has to be a station on the other side transmitting as well. And it's not going to happen if you don't make a sked or there's an activity period. So normally weekends are activity period, and then activity is a little bit higher. You can go to 5260, you can leave your radio on RX, and you can actually copy people making contacts. But mainly over weekends, early in the morning from about 7 o'clock. Other days, evenings, afternoons, there's going to be nothing because nobody's going to be transmitting there just by chance. So patience is key. Right, looking at the setup, I went into WSJ2 quickly, and I made a quick screenshot of the very first settings tab. Right now, this is much the same as FT8. So those of you that used FT8 before, it's much the same as FT8. There's a couple of things that I can quickly point out. Obviously, here you put your call sign and your grid. And if you go down here, you have to enable VHF and submodule features, all right? Submode features. there's also a button here that you must check. If you want to send or receive 73s, you must click that button there that says MSK 144 and 265 TX until 73s are received. 73s is not needed to complete the QSO. It's purely courtesy. You don't need to send 73s in digital modes. So that's why they have some other pile-up stuff as well, which is really, essentially for just working in a specific country or grid. Then the guys are short of time. There's thousands of people that want to work them, and they don't want to spend time on sending 73s, because 273s, to send that via Meteor Scatter might take you 5 minutes just to send 73s. So 73s is not always needed. There's another under additional features. Now the guys that do EME must just check here as well that certain buttons are not ticked. I'm sorry, here under behavior, decode after EME delay, right? So if you're working MSK and you're working EME, you have to take that off to work MSK. If you work EME again, you have to put that tick on again, because there's a delay of 2.8 seconds for your signal to go up to the moon and back again. All right. Next slide. Before I show the next slide, you have to just make sure once you've got your sound card connected or your laptop connected to your radio, it generates a serial port. Okay. Now I'm using an ICOM 705, which is a QRP radio, and I send that to a linear, and I get 150 watts out. So mine creates a COM6 port for my CIV information and for my PTT. So there's two COM ports, one for 6 and one for 3, using COM6 one. So that's why if you set up this screen, you have to set up obviously the type of radio. If you put the wrong type of radio there, I've got 3 ICOMs. If I've got the wrong one there, it will not select test cat. It won't happen. So you have to select your right radio from that list. You have to select the correct COM port. You have to select the correct baud rate. Right. Now the baud rate that you select here must just be the same baud rate that you've got set on your radio. So you can go into the radio settings as well, and you can change the baud rate there. I'm using the PTT method. I'm using cat control. So I'm using the same COM port as there. You can see that one is grayed out. I'm not using that one. All the other ones you can leave as default. You don't have to do anything there. Split operation is really only used if there's Doppler shift. So for flight tracking or EME, there's Doppler shift, you have to use split operation. And then the moment you hit cat, that should go green and it should be connected to your radio. You click OK. On the next slide, your microphone, the audio. Here you select your audio in and your audio out. So mine is also via the same USB card. So I've got my USB codecs for in and out. So it's very easy if your radio has got a USB sound card, but you can select there your microphone and your. So normally on all PCs there's a mic in and headphones. So you use mic and headphones on other types of computer. Yes. All right. So this is your WSJTX screen in MSK mode. Couple of things different from FT8 I want to quickly point out. Now this is the same. The frequency, the band selection and the frequency, that's the same. The station that you're working, you can put the call sign in there and you can look it up. The moment you look up, it puts the grid in there. If you haven't worked in before, you have to manually type that grid in there. That is important because this over here, you can see my azimuth. I might be a bit small for you, but the azimuth here on my side, if I'm pointing from KZN to KG 43 Golf Mike, that azimuth is 332 degrees. It actually gives me two azimuth angles. It gives me direct angle, 332 degrees, and it gives me a B option angle, 353 degrees. Now, sometimes if these two stations are too close to each other, then you beam to the bead angle, all right? So he will have a different angle on his side, but the software selects that we will both be pointing at the same area in the sky that's a little bit further away from us. Okay. You can also see here is a elevation setting. Now, very few stations can do elevation. It's really only the guys that do 6 meter EME that can actually change the elevation on their 6 meter antennas. Mine can't, just point at the horizon, but it still works fine. Normally these antennas are quite short. They are 5 minus a 7 element, and that's short enough to give a very wide spread of radio waves, and enough of them hits the ionosphere where the meteors burn up to actually cause a reflection. That's the distance between us. Here you select your FTOL. When you start out, you can make that 200, or actually on MSK you can leave that at 200. You can even go higher if you want to. 4x 1500 is the max. Transmit receive sequence 15 seconds. Okay, that means I'm transmitting for 15 seconds and then I'm listening for 15 seconds. Then I'm transmitting for 15 seconds and I'm listening. So a time on your clock is very important. So if you just come to your PC and your PC has never been synced to a web server or atomic clock or something like that, then your timing most probably will be out. So if there's only 15 seconds and you only start listening halfway through and you transmit the other halfway through, then we're missing sort of half of the, I'm transmitting and you transmitting at the same time, or I'm listening and you listening at the same time. So what I use on mine is I'm using a Dimension 4. So it's a web server that constantly every, let's say 15 minutes, it actually syncs the time with an atomic clock somewhere overseas. So my clock is always in sync. I never have to worry about syncing it myself or manually. Over here, we've got auto sequence. Now, auto sequence just means that the software, once I receive the 6BON, it will automatically trigger TX2. If you take that off, you have to manually do all of those. If you leave it on, the computer will do that. So it's looking for certain answers from the remote station, from the station that you're working, to actually trigger this auto sequence. Okay. There's another function over here called SH, that stands for shorthand. I'll show you now, just now on the live demo, but shorthand only works for TX3, 4, and 5. Okay. So what it does, it just simplifies the signal that's being transmitted to a single tone. So once you know you're working, so you need those two lines, first of all, to know who you're working. And once you know you're working, you can go to SH and it transmits a single tone, which is a lot easier to copy. So obviously TX3, 4, and 5 is going to be different tones, and you can quickly hear those through the Meteor Scatter. You don't have to have SH on, you can leave it off, and you'll be able to get the call signs for both and the reports. Like I say, 73s is courtesy, you don't have to send 73s. And obviously, if you're just coming on the band and you know there's a couple of guys on, you hit CQ, and your computer will start calling CQ. So if you're north, you go first, you select that first tick box. And if you're south, you select, you deselect that first tick box, and then you'll be second. And also depending where you're beaming. So if I'm beaming to Gauteng, I know I'll have to go second. But if I'm beaming to Cape Town, then I know I'm going to go first because they're going to be second there. All right, let's carry on. So a sample of a QSO flow. Station A transmits for 15 seconds on even cycles. Station B listens. Then responds during an odd-even cycle. You get a signal bounce, so there's a reflection. The exchange completes over successive cycles during a brief meteor reflection. So it is time consuming, guys. It's not something that's going to happen quickly. But remember, you're you're doing space communication. You're not doing a tropo communication or FT8 on 40 meters. This is it's not the same thing. It's anything that's worthwhile is always the more difficult to do. So this is definitely worthwhile. If you tell your mates you've been doing this, 99% of them is not going to believe you. They're going to have to go Google it first to see if there's something like that. Eh? So MSK 444 on 6 meters is both fun and accessible to most people. Minimal setup is needed. Great results for even moderate stations. The optimal setup, horizontal antennas, reasonable power, WX is configured correctly, and awareness of good operating times, especially during meteor shower peaks. This is just the contact that I had with Dick this morning. So you can see I've got my transmit window and my receive windows over here. So this is what I received, the ping. You'll see the video just now live of this, which I recorded, and you can see as it happened. So he called CQ, I replied, he answered me, and we worked through the contact. This is just a summary of that. The different text windows pops up here as well. This is a contact that I did with Johnny, ZS3JDL in Kimberley. He was calling CQ for a while, and then I called him, and we finished the contact. But this over here, guys, is the fast graph. So on there, you can actually see your pings when they happen. I'm going to show you just now on the live video how the pings occur and what they look like. So that bar is normally not on that same window. I've just placed it there for a screenshot that I made. But you can place it somewhere else. If you've got two screens, you put it on another screen, and you can watch that fast graph. When the pings appear, it's going to be, you can actually hear the pings on your speaker of the radio, and you can see them appear. The signal becomes red and sort of jerky. You'll see just now, I've got a demo of that. Over here, you can actually see the SH. They go in different colors, and they like turquoise color over here. If you've got SH ticked, you don't have to have it ticked, but I always prefer to have it ticked. If two guys are really battling to work each other, then SH is much easier to hear a single tone. Right? Okay, this is just a random screen that I'm on, a day that I was monitoring. Johnny was on. Pine ZS6 Oscar Bravo was on. I think there was somebody else calling as well. But yeah, a couple of guys worked each other, and my computer was just standing listening. All the red ones here is where I worked, and the yellow ones is where I called, and all this on this side is where other people called each other. Right, so this is the space. I'm going to quickly just show you the video between myself, ZS6BUN and ZS5Y. And I think I'll have to go out of here. Let me just see. I'm still sharing, so I've just got it on my desktop. Oh, sorry, the wrong one. Can you see my video screen, guys?
100%.
Okay, so this is my screen here. I'm calling CQ on the right hand side. Sorry, I just videoed this with my cell phone. So this is the fast graph, and you can see there's no different markings. Everything is the same. So let me go through the QSO. I'm going to stop again just now. So I'm transmitting now. That's why it's so quiet. There I'm receiving. All right, so you can hear my PC saying calling you. So WSJTX version has got this functionality where it can actually alert you audio wise that somebody's calling you. Now, if your PC, if you weren't even in transmit mode and somebody calls you, your computer will automatically start transmit. But it has to be a call to you. It can't be a call to anybody else. So yeah, here I've got two pings. You can see those times are in the same time frame. They within the first same couple of seconds. Signals were 15 dB. That's the frequency at which they came through. And he's calling ZS5Y. He's been called by ZS6BUN from KG43. He's in South Africa. He's 454 kilometers from me. Sorry, I had to quickly click away there because I wanted to double click on it so that my PC calls him. So what happens now, you'll see that this is now actually going to go to the bottom here, and the new one will appear on top. So there's always a memory of the previous receive cycle. Okay, I'm transmitting now. Now it gets a bit boring because obviously I'm transmitting and Dick is listening to me. And he will see something on his fast graph again while I'm transmitting. So I can hear nothing. I haven't got my monitor switched on my radio. So it's all quiet. I might just fast forward the next couple and not sit here and wait for it. I'll just let you know. I'll show you. There it's me receiving again. You can see it went down to the bottom one. And the new information is now on the top graph. Now, there's nothing in this 15 cycle. I'm not copying anything from it. So that's why I say sometimes you just need patience. He is transmitting. There's just not a meteor between me and him to reflect the signal. Remember, it has to be exactly between us. So, but luckily there's millions of them. So you have to just be patient there. So now I'm transmitting again. Now this is the boring time that you just have to sit and wait. Luckily it's not that long. The whole PSO was completed within five minutes. I'm just showing you what I'm doing here at the bottom quickly. So that's the TX messages. This is the band activity on the left-hand side. Yeah, now if you go on 2 meters and you do the same thing on 2 meters, a contact can easily take 1 hour to get those couple of messages through. Because on 2 meters, those small meteors are even shorter in burn time. So they might be, in a year, they are maybe 10 milliseconds. On 2 meters, it will be maybe 1 millisecond. So it's going to be very, very short, and they don't often reflect the signal. So there comes another one. You can see he's calling me. He's replying to me now. He sent an R8. So this is a much smaller ping than previous, but it's still registered. There. You can see the auto sequence is working. It's going down. So I'm now transmitting RRR. So I'm waiting for Dick 73s now, which is going to come just now. In the meantime, he's receiving the same information that you see on my screen. He's receiving on his end. I'm transmitting again. I'll just pause the day for a while. To make the video a bit shorter. There's the thing again. Yeah, so there you can see he sent me the 73s. That's the ping for that. And yeah, contact is complete. So that was quite a strong ping as well, 16 dB. It was quite intense. Happened at that period. And yeah, that's contact finished. So I'm actually going to go out of the video now. And let me go back to my presentation. Okay, so we were there. Right, so I've got some time for some questions quickly. If anybody wants to ask something or comment something, you're more than welcome to do so now. And I'll answer. Dick is also on, he can also answer. Some of the other fundis, they also here, they can also answer. So go ahead, just unmute and give your questions.
You look at the bottom of your screen, you see there's a hand. It's about, there's a red circle, and 1, 2, 3 to the left. If you show your hand, then you can see who would like to ask a question. It will come up on the screen.
Will I see the hands while I've got the screen on, Hans? Or must I take this presentation off? Yeah, I don't know. I don't think there's any questions. Do you see any hands, Hans?
There's some hands, Frank, you can go.
There's also Stuart and Emil. So Frank.
Okay.
Okay. Can you hear me?
Go ahead.
Yes, we can.
Yeah. Okay, I'm new to that setup here. Can anybody hear me?
Yes, we hear you.
Okay, good. Anyway, thanks for the presentation. And I just thought I'd give a bit of my own experience. Many moons ago, Dave Larsen ZS6GE was running a lab specifically for media burst, how the Americans call it. And he did quite a bit of work. Let me just see if I can get that sharing right here. I don't want screen one. I go to screen or application.
Yes, at the bottom of your screen, the up arrow in the little square block. Oh.
What do you see at the moment?
Nothing.
If you press this sharing, it should ask you what you want to share.
Yeah, I see a screen option, screen 1, screen 2. I click on screen 1, but I don't know how that works.
And see the diagram.
Do you see the diagram? Do you see it?
Yes, we can see the diagram.
Okay. Now then we are nearly there. Anyway, this is an American one, and Americans developed a system to access data from middle of nowhere, where there was no other communications. And their setup is as follows, very similar. They have what they call a master station that transmits 100% duty cycle all the time. And then you get a reflection, and the outstation response, and then a master sends an acknowledge, and then they talk to each other. So let's see if I can go to the next one. Yeah, a very scientific drawing. So here's a master station. It has two antennas because it's full duplex, one for transmit, one for receive. And you can see if you have...
That's the ping for that. And yeah, contact is complete. So that was quite a strong ping as well, 16 dB. It was quite intense. Happened at that period. And yeah, that's contact finished. So I'm actually going to go out of the video now. And let me go back to my presentation. Okay, so we were there. Right, so I've got some time for some questions quickly. If anybody wants to ask something or comment something, you're more than welcome to do so now. And I'll answer. Dick is also on, he can also answer. And some of the other fundies, they also here, they can also answer. So go ahead, just unmute and give your questions.
If you look at the bottom of your screen, you see there's a hand. It's about, there's a red circle, and 1, 2, 3 to the left. If you show your hand, then you can see who would like to ask a question. It will come up on the screen.
Will I see the hands while I've got the screen on, Hans, or must I take this presentation off? Yeah, I don't know. I don't think there's any questions. Do you see any hands, Hans?
There's some hands. Frank, you can go.
There's also Stuart and Emil. So Frank.
Okay.
Okay. Can you hear me?
Go ahead.
Yes, we can.
Yeah. Okay, I'm new to that setup here. Can anybody hear me?
Yes, we hear you.
Okay, good. Anyway, thanks for the presentation. And I just thought I'd give a bit of my own experience. Many moons ago, Dave Larson ZS6GE was running a lab specifically for media burst, how the Americans call it. And he did quite a bit of work. Let me just see if I can get that sharing right here. I don't want screen one. I go to screen or application.
Yes, at the bottom of your screen, the up arrow in the little square block. Oh.
What do you see at the moment?
Nothing.
If you press the sharing, it should ask you what you want to share.
Yeah, I see a screen option, screen 1, screen 2. I click on screen 1, but I don't know how that works.
see the diagram.
Do you see the diagram? Do you see it?
Yes, we can see the diagram.
Okay. Now then we are nearly there. Anyway, this is an American one, and the Americans developed a system to access data from middle of nowhere, where there was no other communications. And their setup is as follows, very similar. They have what they call a master station that transmits 100% duty cycle all the time. And then you get a reflection, and the outstation responds, and then a master sends an acknowledge, and then they talk to each other. So let's see if I can go to the next one. Yeah, a very scientific drawing. So here's a master station. It has two antennas because it's full duplex, one for transmit, one for receive. And you can see if you have an antenna that is very sharp, you essentially only get this outstation. The others don't hear you. But if you have an antenna that has a fairly wide or relatively wide open angle, then you also catch the stations that are a bit offset. You know, if that is your meteor trail, you get a dog leg, and you get a dog leg here too. And here you only go straight. And in extreme cases, we experienced even that stations behind get a reflection. With other words, you transmit and it goes right back to the other station. So that was that thing. Antennas, we used 5-element antennas for 50 megahertz because the 5 elements fit just nicely on a 6-meter aluminium tube as a boom. And it gives a nice, relatively wide beam, not too sharp, and that worked out quite well. Again, another thing is you have the two antennas in full duplex side by side because they see the minimum as each other. So your filtering or duplexer type can be relatively simple. On the receiver, you get away with a sharp band pass to suppress your transmitter signal. The spacing, if I remember right, was about 1.8 megahertz. So not too bad. The modulation they used was also minimum shift keying, but they didn't shift radically. If you look at the amplitude of a minimum shift signal, it is FM, but it also has a strong AM part of it. With other words, your amplifier must be linear. Now, what they did, they shifted the phase gradually over the cycle, and the end result was that there was no AM part, and they could use a Class C amplifier. So that's just a remark to that one. That is what the American system looked like. You had the power supply on the bottom, you had a 1 kilowatt amplifier, you had the transmit band pass, receive band pass, computer interface. So it's quite a rack. Now, that was a unit Dave Larsen's lab developed, power supply, transmitter, receiver. So we managed to cram it all into that. And that transmitter is 1 kilowatt, 100% duty cycle. So you need a decent amount of cooling on that one. Next one. These were the antennas used for Cape Town. So they were fairly high. It was a stack specifically for long distance, like Cape Town and beyond. If you want to be more universal and also have shorter distances, we dropped it down to 3 meters. 3 meters, and then if you have a beam at 3 meters high, you get a nice ground reflect bounce, and that increases your signal on the other end. But when it comes to power, the outstations started with 100 watts. They were semi-duplex, so they were not full duplex. But the funny thing is, if you talk a VHF or UHF and you double your power, it's neither here nor there. Or you even take it 4 times, that's only 60 dB, neither here nor there. But on Meteor Scatter, it makes a dramatic difference, because if you increase your power, all of a sudden you see much more of the smaller meteors, and you get a much better response to increased power than you would normally expect. And that is why they went for 1 kilowatt. Now, you reckon, 1 kilowatt, what do you gain? We had tests with Cape Town, and you could run a teleprinter. At this day, in those years, it was still teleprinters all day long, permanently. But you had, of course, to buffer the data, because like Derek said, in the morning, it's much better than in the afternoon. In the morning, every few seconds to every few minutes, you had bursts. In the afternoon, it could happen that you waited 15 minutes for a burst. Now, you would ask, why is that? It's relatively simple explained. In the morning, the Earth rotates into the path of the meteors. So the meteor is much faster and creates a stronger trail. In the afternoon, the meteors follow the Earth. And it means that, you get less useful trails. So this one is just for interest from a mechanical point of view. This is a bandpass filter, which was used on the receiver. That is what it looks in the inside. I just thought I wanted to say it because of the beautiful mechanics. They have a stepper motor here, which was computer controlled, and you can tune anything between 40 and 60 megahertz. Work of art. And that, of course, had to be redesigned because that is a very expensive unit. And it was designed and redesigned with relays, also digital controlled, not analog like this one. That was one of the outstations that had 200 to 250 watts, semi-duplex. So, yeah, that was an improvement on the 100 watts. The 100 watt had the advantage that it was only half the size, but this one had also batteries inside, so it could run from batteries, built-in batteries. That was the microprocessor part, or computer part, as you can see, lots of till circuits already. That was a power supply. That was a receiver. And that was the transmitter. You can see the actual PA part. And that is a low-pass filter and out. Okay, now I have to get back somehow. Please bear with me.
Press the share button again.
I have only a minimum screen for one reason or another. Stop sharing, let's say. Okay. All right, that was mine.
Very interesting. I remember those days. Dave used to bend my ear many a times on a visit to his farm here in Irene. Thank you very much. Very interesting. But we also have another hand, and that is Emil. Please go ahead, Emil.
Shucks. Can you hear me?
Can hear you.
Can you hear me?
Yes, we can hear you.
We can hear you.
Right. Yeah, just basically two questions. If I'm pointing my antenna up north, do I always go in that direction, or can I move it towards Gauteng area? What is the correct position where I have to point this antenna?
Emil, if you look at the bottom of the WJD screen, if you're just calling CQ and you don't know who you're talking to, just point it north. You should be able to get enough spread for even Namibia or even into KZN. But as soon as you make contact with somebody, his grid will appear on your screen, and then you can just turn your antenna into the direction that it specifies, either the direct path or the A path, if that answers your question.
Absolutely. Thank you very much. And then the second one is, if I need to work maybe a longer distance, say like up into Europe, is that possible? And then I presume I need to use some higher power like kilowatt or 600 watts. I haven't got that type of power right now, but I just was wondering whether this is perhaps the setup what one will need for that kind of contacts.
Emil, MSK won't work for that. What the guys use nowadays for TEP, trans-equatorial propagation, is they use FT8 mainly for that. So Meteor Scatter is not going to work for that. FT8, point to Europe, and just listen, and I'm sure you'll work a couple of stations starting maybe from September, October, November. That's when the TEP is going to peak again. So yeah, you can use the same software, but just go to FT8.
Okay, no, sure, I understand that, but then if you can reach, say, like 2,000 kilometers, is it possible? And will I be able to work into North Africa or higher up in Africa, say, I'm not sure, Zambia, Angola, wherever?
Emil, it depends where you station. Like from me, I can work into Malawi. So if it's within the 2,000 kilometer range, the moment it goes over 2,000 kilometers, it becomes very, very difficult because the amount of meteors that's going to hit exactly at 1,000 kilometers between us is going to become a problem. So I've spent, even with some of the Namibia guys, which is 1,900 kilometers, I've worked them on Meteor Scatter, and you spend sometimes 2 hours and you can't complete. So you get a ping here and there, but you battle a lot. So I would say within Southern Africa, from you into Mozambique, Zimbabwe, Botswana, Namibia should be possible. From Division 1, you're based in Division 1, eh? So from
Yes.
from the Gauteng guys, they can obviously go a little bit further, but for us it's a little bit harder because we're further south. So anything within Southern Africa is a possibility, but Mid-Africa, North Africa, no, it's not a possibility of Meteor Scatter.
Great, thank you very much to everybody. I appreciate it. It was quite interesting. I should start to pursue this type of mode again. I did it 20 years ago, and I can't remember all the detail at that time, but I had a 6-element, 6-meter Yagi. I was trying to point from Alberton down to Cape Town. I wasn't very much successful at that time. Thanks a lot.
Okay, thanks, Emil.
Yeah.
Right, is there any other question? Anybody else like to make the comment? You can show your hand. If you can't find the hand, just unmute and talk. I don't see any. I'm sure there must be more questions.
I'm just going to finish my presentation quickly. Maybe after that they'll have.
Yeah, do go ahead.
Right, so that was questions. Let's carry on quickly. Nearly finished, guys. So always a problem comes up when the guys need yogis. It's either homebrew or we've got 2 builders in ZS. If you're going to grab your phone quickly and take a photo of that screen, you can call John or Pine and they can quote you. My suggestion is going to be 2 meters, 7 elements or more. Bigger is always better. 6 meters, 5 element. You can go 3 element as well. That's just going to be a wider spread. 6 for MSK guys, your antenna need not be high. It's an ideal way to communicate on POTA and SOTA as well. SOTA may be difficult because you have to carry it. But parks on the air, a 3 element yogi, 2 meter high, and you're a for a way to do some MSK on a parks on the air, not a problem. With your 100 watt radio or 50 watt radio. And of course, there's lots of designs on the internet that you can go and find for homebrew if you want to build yourself. Always best to use square booms, much easier to center. I run a WhatsApp group as well for Meteor Scatter in South Africa. And there's my number, Derek 082-852-8552. There's a lot of guys on there already, and there we say when we're going to be active and when we're not going to be active. A lot of other guys in America and Europe, they use web pages to do this on, but because there's so many of them, they can't put them on a WhatsApp group. But we are so few. I think on the WhatsApp group, we've got 10 people at the moment. So just take a photo of that as well or write it down. You can just let me know via WhatsApp and I'll put you on the group as well. And last slide, the end. I hope to hear you are the Space Rocks guys, and 73s to all.